Hello students, straight back again. Today you got your practice problems for section 2.2. Should have already attempted to complete these. Now you'd be checking them. See if you got them right. First one should have been real easy here. You're just switching into scientific notation. As you're doing this, make sure you get the right number of sig figs. This one, we'll get 1 sig fig, so we're going to keep that 5. It'll be times 10 to the nice big number here. We're going to have a positive exponent, in this case 4. Getting our decimal back from here to there. And always keep your units, meters per second squared. A little tiny number here. When I get our decimal down here between the 6 and the 2, those will be our sig figs we'll keep. 6.2 times 10, it's got to be a negative because we've got this little tiny number. And moving it down. On these 0 point numbers, easy way to handle it is just count to zeros. It'll always work. On big numbers, it doesn't always work. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should have moved 10 spots. That makes it a negative 10, and that's kilograms. Next one, another small number, so it's 2.3 times 10 to the negative. Put a decimal there after first non-zero digit. And 1, 2, 3, 4, 5. Again, just count the zeros. On a little tiny number, the 0 point numbers always works. A few more. Big number here. So we're going to end up with 2.13. Decimals got to go here. Now these, it doesn't work just to count the zeros because we got to go beyond the zeros. There's 3, 6, that'd be 7. So times 10 to the 7th milliliters. Another big number. 9.909 times 10 to the 3, 6, 7, 8 meters per second. This particular problem didn't really say much writing on the scientific notation over standard notation. And a little tiny number again, it's going to keep the 4 times 10 to the negative. Again, just count your zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 liters. And number 14. We get to do a little addition and subtraction. When we add or subtract, we must have the same exponent. I always find it easier to change to the bigger one. So I'm going to change this one to 10 to the 21st. I made that up 1, so I'm going to adjust this to 0.510 times 10 to the negative 21st. Then all you got to do is add the coefficients. 0 here doesn't make a difference. I'm going to keep as many decimals as the shortest or smaller number of decimal places is. So we're going to keep 2 decimal places. 2, 6, 4, 4.62 times 10 to the 21st. If they had units on it, you'd need the same units, and then you'd keep the units also. Okay, that's a subtraction, same idea. I want to change it to the bigger one. So I'm going to take this one and change it to something times 10 to the 8. That means I got to move my decimal and make this number smaller, but I got to go 2 spots. So that's going to be a 0.030. 2 spots. Now we subtract 6.20 minus 0.030. And that 0 is not going to make any difference for a subtraction. 20 minus 3, 17. 6.17 times 10 to the 8th. Once you get them the same, all you got to do is keep that exponent. And by going to the larger exponent you use, you're not going to have any adjustments to do at the end. Okay, I got a fifth and third. I'm going to change this one to a fifth power. So times 10 to the 5th. Which means I got to move my decimal back twice because I went from thirds. So that'd be 0.0230. Then we can come back and subtract 2.33 minus 0.0230. Again, just go right there, subtract, get a 0. 30 minus 2, 28. 2.280. 2.280 times 10 to the 5th power. D, another addition. We got -4, -5. We'll change this one to the bigger one again. -4. Made it one bigger. Move my decimal back 0.47 times 10 to the 4th. Then also got to do is add our coefficients. 7, 6. 1.67 times 10 to the -4th. -6, -5, we'll take this one, change it to -5, one bigger, one smaller. Adding 0.620 plus 5.30, ignore that 0, 2, 9, 5. So we got a 5.92 times 10 to the -5th. And F, another subtraction, got a second and a -1. So we want to make this one to the bigger one, so 10 to the second. That's 3 spots, so it's going to be 0.0020. So it's 8.200 minus 0.0020. That 0 doesn't matter. All these other zeros do. 200 minus 2 is 198. So it's 8.198. Times 10 to the second. Now you can do some multiplication division. We tend to do more multiplication and division in chemistry than we do the addition and subtraction. So the multiplication division, we don't have to do any adjusting on the start. But we usually have to do some adjusting on the end. We multiply the coefficients. I do a 12 times a 5. And why they have one here, it's not in scientific notation, it's odd. But that gives me a 60. Then add the exponents. So we got a 4 plus a -2. So we get a 10 to the second. And said we're going to leave our answers in scientific notation, so I do a little adjusting. We only get to keep one sig fig here. So we want to bring our decimal back one spot, make this smaller. We're going to make it a 6. So we make this one bigger. 6 times 10 to the third. And then we got meters times meters, meter squared. Here we got 3 times 10 to the 7th times 3 times 10 to the 7th. Now I'm going to write this one out as a problem like this. A little better way to write it. So we do the 3 times the 3, 9. Add your exponents, times 10 to the 14th. Take care of units, kilometers squared, square kilometers. There's our answer. 2 times 10 to the negative 4th times 2 times 10 to the negative 4th. Millimeters. Millimeters. So 2 times 2, 4. Add your exponents. Negative 8. And then it's going to be millimeters squared. So 4 times 10 to the negative 8 millimeters square, square millimeters. Yeah, switch to a little division. 90 times 10 to the 14th kilograms. Divided by 9 times 10 to the 12th liters. Here we subtract exponents when we do division, so the 12, the 14 becomes a 2. This one happens to be an easy one. 9 goes into 90 10 times. So what we actually have is a 10 to the first times a 10 to the second, which gives us a 10 to the third. And then we'll just put a 1 out here to have it in scientific notation. 1 times 10 to the third kilograms per liter. 12 times 10 to the negative 4th divided by meters divided by 3 times 10 to the negative 4th seconds. 10 negative 4th and 10 negative 4th just divide out. 3 goes into 12 4 times. If it wasn't easy division, pull out your calculator and go through it. So this one's going to be 4, and it said put it in scientific notation. I would just leave it 4 meters per second. With the 10 to the 0, we don't necessarily have to write that. If we did want to write it out in complete scientific notation, it'd be 4 times 10 to the 0 meters per second. I like this answer better. But either would be okay. And one more division. Another division. 20 times 10 to the 15th kilometers. Divided by 5 times 10 to the 11th seconds. Okay, 11, 15 becomes a 4, 10 to the 4th. So we got something times 10 to the 4th. 5 goes into 20 4 times. 4 times 10 to the 4th. Looks like we only get to keep one sig fig. No kilometers per second. And throughout the course of the year, we do a lot of work with doing in scientific notation. Okay, here's a little conversion, and we'll go from meters to centimeters. So we just want to take this thing and we want to change it into centimeters. So 8.847 meters. And 1 meter is 100 centimeters. Meters divide out meters. So we got 884,700. So 884,700 centimeters. Okay, here we want to take 1.56 meters and change that to millimeters. 1.56 meters. Conversion, 1 meter is 1,000 millimeters. I'm going to write it as 10 to the third millimeters. The meters divide out to meters. And I'm just going to leave that's 1.56 times 10 to the third millimeters. Could also, if you had written it as 1,560 millimeters, that's good too. I like to leave them in the scientific notation most of the time. Either answer's okay though. Okay, number 18. We're trying to change from 2.5 gallons of milk per week to liters of milk per week. So all we're really looking at here is changing from 2.5 gallons, and we want to convert that into liters. They gave us a couple conversion factors. We just start with our 2.5 gallons. Real common everyday conversion factor is 1 gallon is 4 quarts. Gallons divide out gallons. And then 1 liter, the other conversion factor is 0.908 quarts. Quarts divide out quarts, and then we do a little multiplying. 2.5 times 4 divided by 0.908. Go into our calculator, doing that multiplication division, 2, and we're going to keep 2 sig figs. That's going to round to 11 liters per week. And number 19. Here we want to know, and it says how many hours are there in a week. So we want 1 week is how many hours. And then it also wants to know how many minutes. So 1 week, in 1 week, you hopefully know there's 7 days. Weeks divide out weeks, and you should know in a day we have 24 hours. Days cancel days. So all we really need to do here is take 7 times 24, which gives us 168 hours per week. Here, because week is an exact counting number, all these are exact numbers, we'll keep an infinite number of significant digits essentially. We'll keep whatever the calculator tells us. And then we want to get that changed into minutes, so hours, we know that. Come back up to our problem. 1 hour is 60 minutes. The hours divided out. So we just take that preceding answer, multiply it by 60, and we get 1,080 minutes in a week. And that takes care of your section 2.2 practice problems. Make sure you understand how to do all this. That's all for now.